When a mountain tunnel was being excavated, a rock fracture zone was encountered. With the collapse of the excavation face, the water outflow was as high as 50 to 80 cubic meters per minute, and the maximum water inrush pressure of the excavation face was as high as 4,000 kilopascal. After coordination by all units, it was decided to abandon a part of the caved-in tunnel, excavate 2 alternative tunnels, and construct a sealing wall in front of the fracture zone to carry out long-hole drilling for hot bitumen grouting, to stabilize the broken rock layer and block the groundwater inrush path. Due to the large scale of the fractured zone and the uncertainty of its extent, after performing horizontal drilling to define the extent of the fractured zone, a long drilled drainage pipe was set up at the works area to reduce part of the water pressure and observe the application of the hot bitumen grout. During grout injection, the drilling depth was about 70 meters. A specially made sleeve valve pipe that horizontally penetrated the fractured zone about 18 to 4 meter, and a special dual pipe for preheating were used to connect the grouting line. The hot bitumen is not easily washed away by water. Meeting cold, the surface condenses into a hard shell. Then when heated, it has the characteristic of ray melting. So it advances forward into the rock fracture zone, filling the cracks and strengthening water stopping. The company carried out a total of 16 boreholes of hot bitumen grouting into tunnel fracture zones. This was divided into 3 stages, in order to avoid polluting the mountain spring water. Hot bitumen with environmental protection characteristics was selected as the grouting material, and natural palm oil was used for preheating. The temperature of the hot bitumen outlet was controlled at about 160 to 200 degrees. The injection pressure was 7,000 till 12,000 kilopascal, and the total pouring volume was about 3,100 cubic meters. After grout injection into 6 boreholes in the first stage, the amount of water in the embedded water pipe had decreased. After completion of grout injection into 8 boreholes in the second stage, return grout appeared in the outlet pipe, and the water volume had greatly reduced. During the third stage of grout injection, the drainage pipe was intermittently closed, and the pressure was partially raised to allow hot bitumen to fully fill the microdetailed surface of the rock layer, and the water flow completely stopped after the hot bitumen was sufficiently cooled. On continuing excavation,